Good morning. So I realized in the first section that this is actually like 15 steps long, which is really significantly longer than I think you guys are going to see in the exam. But I'm still going to go over it. This is the one from Friday. Um, so in order to do this problem, that is a lot of emails coming through. We are going to need to selectively reduce our ketone versus our ester here. If we were to just throw in LAH and reduce both, we're going to end up with two alcohols, and that's going to be a bit of a mess because you can't really protect one over the other. So if I throw in sodium borohydride, I can take this down to just the alcohol for this ketone here. This is going to let me protect this alcohol and go through the rest of the synthesis. If I try to do my Grignard at this point, it's going to be problematic because I have this OH here. I also need to change this functional group, and I'll talk about a little bit why in a second. So if I throw in PCC, or sorry, TMS chloride, I can essentially take this alcohol out of the picture. From here, this is where this gets a little bit tricky. So if I just throw in my Grignard, I'm going to have an issue where I'm going to add either two of these propyls or two of these cyclohexane or pentane groups here. So what I'm actually going to have to do is reduce this again and do a little trick where you oxidize, do a Grignard, oxidize again. So if I throw in LAH from this point, adding in PCC, lets us do these Grignards individually. So from here, we need to do a propyl Grignard as well as this cyclopentyl Grignard. So I'm going to start with the propyl one. So throwing in propyl magnesium bromide. Will get me to here. A mistake I see a lot on these when people are doing them on exams is that they don't actually reduce the ketone when they're doing these Grignards or the aldehydes. They leave them as the aldehyde. But remember, when doing this attack, you're going to end up generating an alcohol at this position. From this point, we need to do another Grignard. So we're going to kind of rinse and repeat this section over here. So throwing in PCC. O, TMS. We can do another Grignard. So the other half of this molecule. I drew that a little weird. Okay. From here, this one gets tricky because this one needs a double protecting group. Like I said, this is much longer than what you guys are actually going to see. So if I throw in TBAF, I'm going to redraw it the way that I can put an OH here. And OH here. I need to add this alpha group. So again, PCC. And this is where this one becomes even trickier because now we have the same situation we had before. We need to add a protecting group. So TMS chloride. Throwing in our Grignard for this ethyl group over here. I'm going to do these all in one step because I'm going to run out of space. So ethyl, Mg, Br, water, and TBAF gets to our final answer. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps. The one on the exam, you get to choose between two of them. I believe one of them is 6 steps and the other one is 7 steps, at least the quickest way you can do it. So you're not going to have one that's this like, I don't know, 12 steps here. So sorry about giving you guys such a hard one over the weekend, but you did have a lot more time. So, and it's good practice. If you can do this one, you'll definitely be able to do the one on your guys' test. Okay, the second one that I gave you guys to do over the weekend, which was a little bit simpler. I'm going to kind of do it a different way. I'm going to break it into pieces and then combine them all together to make a synthesis. So I've got this isopropyl group here. The only place this could really fit in is going to be here. And that means we're going to have to add some carbon-carbon bonds. So we're probably doing Grignards. It would be impossible to do this with an alkyne. Which means we probably are going to need to get to this guy at some point, because this would let us add these groups here. And if I take a look at this, I probably want it to be at some point in time in this position here, where I've got an alcohol, because that's going to be the end of my Grignard. I know how to easily change between these two with PBr3. So these are kind of like our points that we're going to try to hit through our synthesis. So getting from here to here should be pretty straightforward. Getting from here to here should be pretty straightforward. So let's break these down. You could either use Br2 in light or Cl2 in light as your starting reagent. It's not really going to make a difference. My cat likes to yell. So sorry if you guys hear that in the background. So I'm going to add in Br2. From here, whoops, sorry. That should be on the more substituted center. If we throw in base, it doesn't really matter if it's large or small in this case because they're all the same primary positions. I'm just going to write down base. we can eliminate. We want a aldehyde here, which we could either do, we can't make an alkyne, so we have to make an alcohol and oxidize. So BH3THF, NaOH, and peroxide gets us here. Throw in PCC, we can get to our ketone or aldehyde. We need to add these groups here. So let's do the ethyl first. Magnesium bromide. Gives me this alcohol. Oxidize it in order to do this reaction again. So we can throw in PCC. From here, I'm doing the exact same thing. So this guy with the magnesium bromide, MgBr, water, and then this last step here, I'm just going to throw in PBr3. Okay, so that's these practice synthesis problems. I'm going to go through all of the practice exams now and tell you guys which ones you don't need to do because we didn't do chapter 13. It's kind of a lot of them, so I'm just going to take a few minutes to kind of go through that. So I'm going to start with the old exam. So fall 2020 exam. Taking a look at your nomenclature. We did not learn ethers and epoxides, at least in terms of naming. So we can cross these two out. For NMRs, I'm not going to test over ether NMRs. We're just going to do alcohols and alkyl halides. So we can cross this bottom one off. This would have been an ether if you were to solve it. We technically learned how to do this, but I'm just to be consistent. This is a chapter 13 concept, so I'm not going to cover it. Looking at the reactions page, we didn't do this or this or this here. So epoxide on the right side, 2, 3, and 5 didn't get covered. Most of this next page did not get covered, so we didn't do these. We did this, didn't do this. This one you can do, this one you can't. Cross out this whole bottom. So most of this page is from chapter 13. And then the rest of that exam you can do. Taking a look at 1.1. So practice exam 1.1 in terms of naming, can't do this top one, didn't learn epoxides, can't do this bottom one, didn't learn ethers. We can cross out the first NMR, that was an ether. Going to our reaction page on the left, nope, right side, everything from 3, nope, the whole thing, well, whole left side can be crossed out. Let's see, name the, or fill in the products, everything 2 and down should be crossed out. You can do both of the mechanisms, and then this first synthesis here should be crossed out because that uses a epoxide. Um, 1.2. It looks like you can name all of those. On the NMRs, bottom one is an ether, so you can cross that out. Going to the reaction page. Let's see, this one, this one, this one, this one here. So 1 on the left side, 3 on the right side. Taking a look at the fill in the reagents page. Didn't learn this one. Didn't learn this one. I think this whole bottom you can't do. So kind of like the last one, a lot of this was chapter 13. You can do the mechanisms, and then this bottom synthesis one is one that we can't do. So I'm gonna actually start with this synthesis that's on this page and go through some of these. So this was an exam we gave spring 2020, and I'm gonna talk about why people did bad on this or where people went wrong in this one. So for this top synthesis problem, this here most likely fits into this, which means we need to add a 5-carbon ring with a methyl on it through a Grignard. And that's pretty much the first thing we can do. So throwing in MgBr with water here. And the reason people got this wrong, so I'm going to draw the correct answer from this step, and then I'm going to draw what people drew. So this is the product from the reaction. These 2 electrons here are going to attack your ketone or your aldehyde here. You're going to get an alcohol that is in this position here. What I saw mostly on this one was either, there were 3 different things that got drawn a lot. This. So in order to get this, you would have had to attack at this center, which you can't really do. The other thing that seems to trip people up a lot is with aldehydes, ketones, they don't seem to have an issue, but with aldehydes especially, they will draw either, and I'll just do the one because the other one would be the product. This as their product. For whatever reason, aldehydes, people don't think to reduce them to the alcohol. They just like to leave them as the ketone, but that isn't going to work because that's not what the reaction does. So my advice on these is like when you draw a reagent that you think is going to work, draw the product it should have, not the product you want. Because it seems like people will jump straight from here to here because this would be easier to work with, but that's still not what the reaction does. So from here, how do we get to here? We're kind of going to do a little bit of a shuffle followed by an oxidation. So there's a couple of different reagents you can use to do this. We're going to need to change this to something that's a better leaving group. So I'm going to add in SOCl2, pyridine, to make this into a chlorine. From the chlorine, a large base can get me to here. And then now we're just doing our BH3THF followed by oxidation. Two big carbons. All right, I'm going to draw this in this little space. With an OH, we can throw in PCC and get to our final product. So yeah, for these ones, just kind of watch out when you're doing these reactions. Make sure you're getting the product you're supposed to get and not the product that's going to make it easier. On the exam, we have to name, large base, or you can just put base. That's fine. Yeah, I'm not going to make you guys label what type of base you're using. On later in the class, like chapter 20 something, we start doing them again, and I'll have you guys specifically label which bases at that point. Okay. I'm going to talk about, I think this is exam 1.1. I'm going to do the other synthesis problem. Which is pretty similar, except in this case, we're using a protectant group. So for this one here, it's pretty obvious we're going to have to do a Grignard at some point and add in this large group. And we're probably going to have to shuffle our OH here. We have an alcohol that doesn't do anything, so we're going to want to just kind of throw in TBAF immediately to kind of take that out of the equation, or not TBAF, throw in TMS chloride. So now we want to do a Grignard. We want to add 1, 2, 3, 4. So we need some sort of butyl Grignard. And this is another reaction that tripped people up. So just the reaction itself, MgBr in water should get me this alcohol here, where my alcohol is at the same position as the ketone was. For whatever reason, this exam, people really wanted the alcohol to be over here because that would make the next step easier. But that's not what this reaction does. So again, we need to kind of shuffle and reoxidize. So we're using the same steps as we did before. SOCl2. Can put a chlorine here. We are going to use a large base. And this is legitimately the same steps as the other one. We can throw in BH3 followed by PCC. Oops, that should not be this. This needs to be the OH here. Oh, TMS. Our last step is going to be taking off that protecting group. Oops. TBAF will allow us to get to taking this off to give us our alcohol back. Okay. I am going to switch gears a little bit and talk through a few NMRs, and then I'm going to do a naming problem and then open it up to the floor. So let's take a look. Where am I at? I'm at 1.2, the one I liked. Yeah, so practice exam 1.2. This naming one at the bottom for this alcohol. I haven't really talked too much about these cyclopentyl groups here. If you have a cyclic group, your numbering is going to start on whatever your highest priority group is. So in this case, we have an alcohol, and that's going to be our group that we're going to use for all of our numbering. I'll draw this in regular pen because I think it's going to be a little easier to see. So we're going to put a 1 here. And then for going around our circle, we just want the lowest number we can have. So 2, 3, 4, 5. Clockwise is going to be significantly less than if we went 1, 2, 3, 4, 5 here. This is a cyclopentanol. You could write cyclopentane 1 all if you wanted to. You don't have to. If it's on 1, it's implied that if you just write it out, that it's the one that's on 1. Let's see, on 2 we have an ethyl. On 3 we have a methyl here. Oh, for these rings, if you ever have a situation where it's perfectly symmetrical, let's say we have this here where we have 1, 2, 3, 1, 2, 3. It's going to give us the same number either way we go. This is an ethyl group. This is a methyl group. It's actually just going to go alphabetical. So in this case, 1, 2, 3, 4, 5 is going to be the favored because you're hitting 3 on the ethyl versus 1, 2, 3 on the methyl here. It just favors the alphabetical when it's perfectly symmetrical. Okay, doing RNS. I'm gonna redraw it. I might redraw it a couple times. Should be dashes. Okay, so OH here is our highest priority. Colors. We've got carbon with a bunch of stuff versus single carbon chain. This will be 2. This will be 3. Our lowest priority group is in the back position. or sorry, is in the wedge position, which means we're gonna have to flip it. Anytime you have 4 that's on a wedge, we end up flipping it. So this should be going clockwise, but because H is forward, this is going to be a 1S here. Taking a look at this center number 2, H is on a dash, so we don't have to worry about it. We have carbon attached to an ethyl, carbon that is bonded to an OH, carbon bonded to 2 carbons. So this is going to be our highest, second highest, third highest here, counterclockwise. We got 2S. Last one here, we again have an H that is in the wedge position, so we're gonna have to flip it at the end. Taking a look, what we have here, we have a CH3 carbon bonded to a carbon chain, carbon bonded to 2 carbons in a chain, so this is gonna be our highest. Second, third, this would be S, but it's gonna be R. So this is a 3R here. Putting it all together, I'm going to write it up top because I'm going to run out of room if I don't. This should be 1S, 2S, whoops, I got ahead of myself. 3R, E comes before M, so 2 ethyl, 3 methyl, cyclo, pent, and all. Question in the chat. Isn't clockwise an R configuration? So typically it is. Anytime you have your lowest priority group in the forward position, which would be this wedge here, you need to flip whether or not you have R and S. You technically could rotate your entire molecule, but it's easier to just kind of say, this is a wedge, I need to flip everything. Okay. Did I do NMRs? I don't think I did NMRs yet. So I'm going to pull out some NMRs, and then I'm going to open it up for any questions from you guys. So let's see. I'm going to do this one from practice exam 1.1. I'm going to do the NMR at the bottom. This one's a little tricky. Figured I'd go through it. We have an OH because we've got this little guy down here. We have a CH2. My camera's fuzzy today, but we have 2 CH3s. And then we have a CH3 here. Taking a look at the number of peaks, we have 4, so this should have 3 neighbors. 1, so this should have 0 neighbors. And 3, so this should have 2 neighbors. All right, so where to start on this one? So there is nothing here, which is our typical bonded to OH. We have 1, 2, 3, 4 signals, but there are 5 carbons. And that means that whatever is attached to our OH, there's some questions in the chat. If it doesn't say wedge, sorry, so there's some questions on the nomenclature. actually a couple questions in the chat. For one, we're not going to cover the NBS mechanism, Alice. And then if it doesn't say wedge or dash, you don't have to do RNS. And yes, you'll be given, it's this page here. You're going to get this at the back of the NMRs. So you don't have to memorize them. Okay, nothing in this 3 to 4 range here, which means that the carbon that's attached to our OH doesn't have any protons. It's not giving a signal. And this makes sense also because we have something that is bonded to something with 0 neighbors on it. So we can throw these CH3s on here. They are supposed to have 0 neighbors to them. They currently would. We got one opening left. You have a CH2 and a CH3. It can't be the CH3 because that would end our molecule. So putting our CH2 on there should have 3 neighbors. Putting our CH3 on there would finish this off. Labeling these A, B, C, D here. A is going to be our OH. B is going to be our CH2. There's only one of them. C is going to be our symmetrical CH3s. And then D would be this other CH3 here. I'm going to do the other NMR from 1.2. Okay, so again, we're dealing with an alcohol here. We've got an OH. This time we do have a peak between 3 and 4. It's a CH. We've got 2 symmetrical CH2s, 2 symmetrical CH3s. Generally, when you have this, when you have a CH or a 4H and a 6H, it's going to be some sort of like W type chain where they're connected to each other in a really long system. Taking a look at peaks, this is 5, should have 4 neighbors. 5 again, should have 4 neighbors. 3 should have 2 neighbors. We got a peak between 3 and 4, so that gives us a nice starting place. It should be a CH. It's got our OH on it. It's supposed to have 4 neighbors, so 2 CH2s. Each of those CH2s are supposed to have 4 neighbors. They currently have 1 from the CH, so they would need a CH3 on either side. Okay, labeling A, B, C, D here. A is going to be our OH. B is going to be our CH here. C is our symmetrical CH2s. And then D is going to be our symmetrical CH3s here. All right, I'm going to open it up to you guys. For your exam, it'll be formatted very similar to the fall exam. You're going to have a page with 4 nomenclature questions. You'll have an NMR page where you pick between the 2. You'll have a reactions page. I think there's 10 reactions on it. A fill in the reagents. There should be 10 of those also. A page with a mechanism where you pick between the 2, and a page with the synthesis where you pick between the 2 also. Are there any questions from you guys at this point? the exam is held in the Lead Center, I recommend bringing either a textbook or something to write on, like a, what are those called? Clipboard. Some questions. So we just have to choose one of the NMRs. Yeah, so if you read the actual instructions from the fall exam, says draw the structure of one of the NMRs, label the peaks within its position, place the box around that structure. If you do both structures, we'll grade the first one. So draw out your structure. If you end up filling in both of them, put a circle around the one you want to grade. Same thing for the synthesis as well as the mechanism questions. Someone asked if the exam starts exactly at 10:30. So yeah, there's a exam before this for the 9:30 class. So as soon as you're in and you have your exam, you guys can start. But for the most part, yeah, it's starting then. You have 50 minutes for it. Someone asked if there's any suggested second language book problems. I'll check with the TAs, see if they have any ones that they want you guys to do for that. Yeah, and if you need to do the exam online, send me an email after this and we'll I'll add you to the list of people taking it online. And I'll give you the details for that. It's very similar. You need a printer and something to take photos with, usually a cell phone. Yeah, so when you use PCC versus when you use chromic acid, let me pull up. You use PCC when you want to do a single oxidation. So for this one here, I'm going to pull out this last reaction and talk about why I use PCC. And what would happen if I used NaCl. So we said PCC here because we wanted to make an aldehyde. If we were to instead add in Na2Cr2O7, H2SO4, and water, this would have oxidized fully to the carboxylic acid. Because this is primary here, it's got two H's that can be oxidized. So this is an example where you have to choose between the two of them. If it's secondary, it generally doesn't matter. But if we'd done this, for one, we get the wrong product, but also you're kind of stuck with a carboxylic acid here. Any other questions? If not, I'm going to be on office hours for the next. Oh, wait. Someone asked, can you go over when we use NaBH4 versus LAH? Yeah, so I'm going to pull up that first example that we did when we were talking about synthesis. If I use NaBH4 here, in methanol, this is selective for aldehydes and ketones. So this would let us differentiate between these two. If I just threw an LAH, I would have gotten this. And then if I tried to protect it with TMS chloride versus over here, I need to get rid of that. I can get an OTMS. Over here, I'm going to run to the issue where it's going to protect both of them. And then if I try to get it off, I'm going to get off both of them. Oops, did I lose Zoom? Where am I? Nope, there we go. Okay. So this is an example where you need to choose between the two of them. A lot of the times you can use either one, but it's when you want to selectively reduce a ketone versus an ester. This is an example when you need to do both of them. On the mechanism part for the exam, we're likely to be tested over mechanisms we learned in OChem 1 and briefly covered in OChem 2. I sent out an announcement with all the mechanisms that we kind of talked about. I do think actually hydroboration oxidation I accidentally put on there, and we're not going to talk about that one. That's like the BH3-THF one. But for the most part, anything that's on that list is fair game. Although I do think I mostly favored the ones that are newer. Anything else? How many questions are there going to be? So like I said, there's 4 nomenclature, 10 fill in the reagent, 10 fill in the product. You do 1 NMR, 1 synthesis, and 1 mechanism. Okay, I will be in office hours starting at noon. If you guys have any questions, you can also email me. And I will see you guys on Wednesday.